Good morning, guys. Yesterday, we have started design of the column bases. We have designed analyzed the column base. We get to know about what is column base, what is the requirement of a normal column base over a concrete slab, what are the types of column bases. We have discussed about gusset base, we have discussed about normal slab base, then we have discussed the normal design procedure for the normal design procedure for the column base, that is a slab base. Okay, then we have seen an example. Now for today we will discuss the second topic, the final topic for this column base design, that is the gusset base design. What is gusset base? Then we will design. In the earlier class, in the previous class, that I have told you that if the load on the column is much more higher, load on the column is too large, okay, and also the axial load sometimes may be accompanied by bending moment, usually a gusset base is applied. A gusset base is generally used. The gusset base consists of a base plate and a gusset plate. Base plate to gusset plate at two flanges of the column, and for two flanges of the column. If there is a welded connection, there is no need for extra gusset angle, but if it is a bolted connection, a extra gusset angle has to be provided. Okay, in this picture we can see this is a bolted gusset place, this is a welded gusset place. Okay, it is a bolted gusset place, it is a welded gusset place. Now in the bolted gusset place, what is the difference? Is that this part causes the main difference between the welded gusset plate and the bolted gusset plate. This is called what is it called? It is called the gusset angle. The gusset angle, why it is used? It is used for a connection between the gusset plate and the gusset plate and the column base. So the gusset plate, gusset angle and the column base all are in the connection with the column. But in case of the welded gusset place, there is no need of this gusset angle. Only the gusset plate and the column is connected by the help of weld. Okay, by the help of weld. Now these are the foundation bolts that are provided. Anchor bolts are provided. It is provided, you should be knowing, because in the previous class I have discussed what is the need of these anchor bolts to proper connection between the base plate and the concrete member below the base plate, concrete pedestal below the base plate. So what is the main basic difference that I have discussed for base plate, column base and gusset base, welded and bolted connection? That is, in case of bolted connection there will be an extra gusset angle, and in case of the welded connection there will be only the column and the gusset plate which is connected to the gusset base. So this is the basic theory of the gusset plate design. Now coming to the design principle of the gusset plate. The design procedure will be somehow similar like the normal column, the normal slab base, but as there are some gusset plate is there, so the design principle will differ by some degree. Now first, step one is similar to that of step one of normal column slab design, normal slab based design. That is, the first, a suitable grade of the concrete has been assumed. Depending upon the grade of the concrete, bearing strength of the concrete. Clause number 34.4, I think you may have no clause number 34.4. If you want to know, then again it is specified here that 34.4, okay, 34.4, okay, in the 34.4 it is specified that the limit state method, the design, the permissible bending strength shall be 0.45 fck, but here it is specified that the bending strength to be 0.6 fck. So it should be taken as, it is not taken as 0.6 fck. As per IS 456, the value to be taken as 0.45 fck. That value to be taken here. So 0.45 SEK will be the value of the design bending strength of the concrete. The first, it is determined design bending strength. Then the area of the base plate is determined by A is equal to P by bearing strength of the concrete. We have calculated here bearing strength of the concrete and the load applied, PU. PU is the load applied, will be calculated the area. Now coming to the step number 3, which is the first important step. Now gusset material is one thing. Gusset material for a normal bolted base, what is the gusset material? The gusset material is the gusset plate, gusset angle, gusset plate and the gusset angle. Here the gusset plate and the gusset angle, these two combine are called gusset material. So it is being specified here. Gusset material is assumed. Gusset material is equal to gusset plate plus gusset angle for the bolted connection and normal gusset plate for only welded connection. So this is the normal welded connection. Here only the gusset plate is provided. So the gusset material for welded connection is the normal gusset plate, and for the bolted connection it is gusset plate plus the gusset angle. So this is to be concerned. Now for a gusset plate, first criteria is the first criteria for a gusset plate assumed thickness should not be less than 16 mm. So first we will assume the thickness of the gusset plate to be more than or equals to 16 mm. That means thickness of the gusset plate should be greater than equals to 16 mm. First important part it is. So thickness of the gusset plate should not be less than 16 mm. It should be equals to or greater than 16 mm. First one. Second one is for gusset angle, the length and the width is so chosen that it can fit 2 rows of the bolt in vertical leg and 1 row of the bolt in horizontal leg. So an unequal length. That means if this is an angle, this is the gusset angle to be so chosen that it can provide 2 bolts in the vertical leg and 1 bolt in the horizontal leg. So if there are 2 bolts in the vertical leg and 1 bolt in the horizontal leg, always a unequal section to be selected. Now coming to the question, how the unequal section has to be selected, what is the criteria for the selection of this unequal section? Now the selection criteria is the pitch and edge distance. Consider there are 2 bolts in the gusset angle here and that 1 bolt is here. So this distance between the 2 bolts is called the pitch of the bolt. This is P. So P is equal to, so here P is equal to pitch distance, E is equal to edge distance. So the selection criteria for the angle section, the gusset angle, will be based on the pitch and the edge of the bolt. So first we have to assume some first we have to assume some diameter of the bolt. So depending on the diameter we have to select the minimum pitch and the minimum edge distance. Then we have to provide the pitch and the edge distance. Depending on the pitch and the edge distance we will get the value of the angle section, which angle to be selected from the IS handbook. From there we will get the value. Next criteria is thickness of the gusset angle should be always kept equal to the gusset plate. That means if the thickness of the gusset plate is taken greater than or equal to 16 mm, the thickness of the gusset angle to be selected based on that value. So if it is 16, the thickness of the gusset plate should also be 16 mm. Then coming to the length of the gusset plate, this is the very much important, is the length of the gusset plate. Now the length of the gusset plate and the gusset angle should be kept equal to the length of the base plate. That means if the base plate having length equals to L, then the length of the gusset plate and the length of the base plate will be same value, like the base length of the base plate. Now for the welded connection, consider this is a welded connection. Consider this is the welded connection. So this is one type of connection where this is the flange that are connected with the welded plate, so that proper bonding is available. proper bonding is available. This is the welded connection. So for the welded connection, depth dimension of the base plate parallel to wave, that means this is wave. Dimension of the base plate parallel to wave is equal to B is equal to depth of the, this is the B is equal to depth of the section, that is that value, depth of the section plus 2 into thickness of the gusset plate, 2 into thickness of the gusset plate, this is the 2 thickness, and overhang, this is the value of the overhang. So this is the amount of the for welded connection, this is the dimension of the base plate. Now we do not know how much overhang to be provided. So in the first case, I will show you in the math also that in the first we will neglect this value of the overhang. We will first neglect the value of the overhang and we will take the value of the only depth of the section and the thickness of the gusset plate. First we will assume that, then from that value we will get the overhang. I will, in the math I will show you. Now for bolted connection, this is the bolted connection. L, that is the length of the plate, that will be equals to depth of the section, that is the depth of the section, plus 2 into thickness of the gusset plate, this is the gusset plate, 2 into thickness of the gusset plate. Now for this plate, deep from here to here, this is the, from here to here, this is the outstand leg length. Consider this picture. Here, from here to here, this is the outstand leg length of the angle. So 2 into, so outstand leg length of the gusset angle plus overhang. This will be the formula for a bolted gusset plate connection. Very much important. We need to understand it very much carefully. Why outstand leg length? Consider the leg length is like this. So this is the outside leg length L0. So L0, that is the outside leg length, that is this value. L0, the outside leg length, how much leg length outside is provided, plus the overhang. Here you will also limit the overhang. Now the other dimension, so here we are calculating one dimension L and here we are going to B. So the other dimension will be calculated, the area we have calculated, A equals to, we have calculated the area, then other dimension will be the calculated area divided by the dimension. Here we have calculated the area required we have calculated, so required area divided by the calculated dimension, we will be getting the value of the total the other dimension. Okay, finally the size of the, so from here the size of the base plate is determined. That means the L and B, that is the dimension of the base plate, is determined. So our motto of the base plate design is to find that dimension and the thickness. So we have found the dimension, then we will go for the thickness of the, but before we find the thickness of the gusset plate, another important thing we have to, this is in step 4, height, the important thing we have to find out. Now height of the step 4 states that height of the gusset plate is determined by number of the bolts and edge distance for the bolted connection and the length of the weld to be accommodated. That means if this is the, this is the bolted connection, if this is the bolted connection, then if this is the gusset plate, then the height of the gusset plate will be calculated depending upon the edge and the pitch of the bolt. And for a bolted connection gusset plate and for a welded connection gusset plate, the height of the gusset plate will be calculated depending upon the length of the weld provided. That has been written here. Height of the gusset plate is determined by number of the bolt rows. Consider there are 3 bolts, 4 bolts, number of the bolts row, and for a bolted connection and length of the weld to be accommodated. Now upward pressure below the base causes the bending of the gusset plate, and due to this their top edge goes into compression, which may buckle. That means if it is a base plate, if it is a gusset plate like that, now from the bottom a bending pressure is coming. Due to this bending pressure, the top portion this top portion will act as a compression member. This top portion will act as a compression member, and due to this compression member it will try to buckle. So a buckling check here has to be done in step 4. So therefore the buckling of the top edge to be checked. How to check? So if these two conditions are satisfied, d less than equals to 29.3 epsilon into tau g, that is the Tg equals to the thickness of the gusset plate. Tg equals to the thickness of the gusset plate, and epsilon equals to, you know, that is the yield stress ratio. So if these two conditions are satisfied, then we can say the gusset plate, top portion of the gusset plate is safe in buckling. So what is the meaning of D? Portion of the gusset plate welded to the column flange. Portion of the gusset plate welded to the column flange. That means this is the value of the D. So this portion of the gusset plate is welded to the column. That means this is the column, this is the column, this is the column. So this portion of the gusset plate is connected to the column. So this is equals to D. Okay, because this is the gusset plate. Now this portion is connected to the column, so this is D, and S0 is equal to slant edge. This is the slant edge value. What is the value of the slant edge? Then if we know this distance and this distance, we can determine that distance by the Pythagoras' formula. So what is this distance? This distance is the outstand leg of the gusset plate. This distance is the outstand leg of the gusset plate, and this distance is the difference between the height of the gusset plate and the slant height starting. So here the slant height is starting from here, and this is the point, the connection of the gusset plate. So this distance and this distance, if we determine these two distance, we can determine the value of the S0, that is the slant edge, that value. This is the S0. So we have to determine that and that. Okay, in the math we will see that how to determine these two values. And outstand leg of the gusset plate will be equals to length of the gusset plate, length of the base plate, that is, this is the length of the base plate, minus depth of the column, this is the depth of the column, and by 2. We will see also in the math how this formula comes out. This is the step 4. Now as step 4 is as in the step 4, the height of the gusset plate we need to determine. As in step 4, the height of the gusset plate we need to determine. So the number of the bolt rows in the gusset plate we have to determine. So please make it sure that we first determine the number of the rows of bolt in the gusset plate. Okay, so this is step 4. Coming to step 5, determination of bearing pressure. It is same as in the case of the normal. It is same as in the case of normal slab base, that is W is equal to P by A1, which it should be always less than 0.45 FCK. This has to be taken care of. Okay, now next coming to how to determine the thickness of the gusset plate. Now determination of the step 6, determination of the thickness of the base plate. How to determine the thickness of the base plate is step number 6. Up to this step we have determined the size of the base plate. Now we will determine the thickness of the base plate. Now here we have to determine the critical moment. What is the critical moment here? What is the critical moment? The critical moment here, we have to determine the critical moment. What is the critical moment here? If this is the critical zone, this line, this line is the critical zone of the bending moment. So for critical moment is calculated by m into w into c1 square. Now W value we have calculated from here, that is the bearing pressure. C1 is that distance from the edge of from the starting or from the end of the base plate, to that value, that is that value. This is that distance is the C1, that is the C1 is a portion of the base acting as a cantilever. Now, what is a cantilever? Cantilever means that thing which is suspended. Consider this one is connected with that plate, so it acts as a cantilever. How? This one is fixed. This one, so that portion is fixed here. That portion is fixed here. Okay, that portion is fixed here. Now this length is here. That length is here, so it acts as a cantilever. So it acts as a cantilever. Okay. So this is ISSP6 we are taking. So if ISSP6 we follow for unequal angles, this is equal angle, this is unequal angle. So we have to see that this criteria and this criteria is fulfilled. So for 145, so it should be greater than 145 or equals to, so 145, this is 150, so we can take that 150, we can take that as 150, but another leg is 80, so we cannot take that, we have to take this value. So this is the size of the leg. Now what will be the thickness? In my note it is said that the thickness of the gusset angle should be always kept equal to the gusset plate. Now what is the thickness of the gusset plate we have taken? Thickness of the gusset plate is 16 mm. So if the thickness of the gusset plate is 16 mm, so the angle thickness will be also 16 mm, but here there is no value such as 16, so we will take 15, that value we will take. So providing an angle 150 into 115 and 15 mm unequal angle, so this unequal angle we will take as the value. Now so angle value has been taken, so now coming to the dimension of the bolted connection. Now for bolted connection, the length is equal to will be the minimum length required equals to that formula we will use. So depth of the section plus 2 into thickness of the gusset plate and outstand leg plus overhang. Now neglecting overhang because we do not know the value of the overhang, because we have to provide the overhang, so we are first declining the overhang, neglecting the overhang. So depth of the section, that is the text of the column, that is for it is ISHB, I think it is ISHB 350. So depth of the column 350 plus 2 into thickness of the gusset plate 16 plus outstand leg length of the gusset plate. Now what is the outstand leg length of the gusset plate? In this case, this is the outstand leg, this is 115. So 115 is the leg length, outstand leg length. So it is coming to 612 mm. Taking it as 620 mm as the required length. So increasing the value, so that increasing the value. So now as we are taking some higher value, this difference of the higher value will give the value of the overhang. So the overhang or the projection, so 620, the total length 620, we are providing 620 by we have got 612. So this and this will be the overhang. So the overhang is equal to 620 minus 612 by 2, that is 4 mm overhang in each side. So here it is 4 mm, here it is 4 mm. So this is the 4 mm overhang. It is been said here, it is also shown here, this is the 4 mm overhang we are providing here. Now so another dimension, the width of the base plate will be equals to it is shown here, the width of the base plate will be equals to L by or B equals to A by the calculated dimension. So A equals to, we have calculated A equals to 251.185 here. So that divided by the area, that is 620 mm. So we are getting 406.2. So again 410 mm we are assuming. So providing a base plate of 620 into 410 mm for our case. This is the size of the base plate we have got. Now what is the step number 4? So now step number 4, here we have to determine the height of the gusset plate. Height of the gusset plate is determined by the number of the bolt rows in the edge distance. Now we have determined the number of the bolts in the gusset angle, but we do not have the number of the bolts for the gusset plate. The number of the bolts required for the connection of the gusset plate and the base plate with the column will be determined depending on the load capacity. So it will be done in the next step. So step number 4 will be done here later, because height of the gusset plate depends on the number of the bolts in the gusset plate. So first number of the bolts will be calculated. So for calculating the number of the bolts, we need the thickness of the section. So for calculating the number of the bolts, we need the thickness of the section. First the thickness of the section will be determined, then we will go for the step number 4. It will be in the next step. So step number 5 we are taking now. So what is step number 5? Step number 5, determination of the bearing pressure. W is equal to P by A1. So W is equal to P by the area provided. So A area provided is equal to A1, that is A1 is equal to area provided. So 1700 to 10 cube the total load, and area provided is equal to that value, 600 into 400. So 6.68 Newton per millimeter square. It is less than 6.75 that we have get. So it should be less than 0.45 FCK, which is 0.45 FCK is equal to 6.75. So this value is less than 6.75. So hence okay. Now coming to the step number 6, here we have to determine the thickness. So first we have to determine the value of the C1. C1 equals to, from here to that value. Now here C1 will be equals to, C1 will be equals to, if we see in this picture, this is C1, so this is 4, and from here to this will be equals to, if this is the angle, we have to take from here to here only. So it will be 115, this is 115 minus the thickness, that is 15, that is equals to 100. I have showed it, I have also shown in here, that is 115 minus 15. For this case 115 minus 15, this is that one plus 4. So plus 4, that is the cantilever portion size. So for the critical moment, W is equal to, for putting the values here, MCR is equal to MXX. The section is in XX, so MX is equals to that value. So the moment capacity, there is the design bending strength is equal to that value. T is equal to, have to determine. So putting all the values here, ZD, FY, all the values, we are getting T is equal to 28.19. Now, very important part. What is the value of T? T is equal to aggregate thickness of the base plate and the gusset plate for bolted and for bolted. So aggregate thickness of the base plate and the gusset plate. So aggregate thickness of the gusset plate, gusset material, this is the gusset plate plus base plate. Now what is the thickness of the gusset plate? We have assumed the thickness of the gusset plate to be, we have the thickness of the gusset plate to be 16 mm. So 29.16 is the value coming. 28.19 minus 15 mm is the thickness of the gusset plate, that is 13.19, taking it to be 16 mm. So thickness of the base plate equals to 16 mm. Similar, so 16 of mm is equal to thickness of the base plate, and 16 mm will be equal to the thickness of the gusset plate. So step 6 is complete. Now step 7, this is step 7. Step 7, okay. Now coming to step number 7, holding down bolt for 2 or 4 number and 20 mm dia. So here we will provide 2 number of holding bolt. It is not shown here. Step 7, it has been skipped, but you have to do it. So step 7 will be 2 number of 20 mm diameter bolt will be provided here. Now coming to the design of the connection. So if the column or base plate are connected and assumed to be in perfect condition, then 50% of total load will be passed directly and connection and will be designed for rest 50. So assume here no condition has been said. So assuming a complete bearing between the base plate and the column, therefore the connection will be designed for the 50% of the applied load as per said here. So 50% of the total load will be passed directly and connection will be designed for 50%. So 50% of applied load. So strength. So first that for bolted connection we have to now coming to the so the connection is bolted connection. Very much have to remember that connection is bolted connection. So for bolted connection, the strength of the bolt is determined in single shell. So strength of the bolt in single shell is equal to 65.21 for 20 mm dia bolt. A and B value is equal to 353 mm square. So 65.21 is the value of the strength of the bolt in single shell. So coming to the number of the bolts required will be equals to total applied load. Now what is the applied load? PU by 2. Why PU by 2? Because 50% of the load, the connection will be designed for 50% of the load will pass through the connection. So the connection will be designed for PU by 2. So PU by 2 equals to that value 17,000 by 2 by 65.21. This is equal to 13.03 nos. Now taking the value as 16 nos. Why? Because it is advisable to put similar number of bolts in the angle as well as the gusset plate connection. So if we as equilibrium connection, 16 number of bolts are provided, 8 number for connecting the gusset plate with the column and 8 number for the connecting angle with the gusset plate. So 16 numbers of bolts will be provided. So these are the first 16 number of bolts which are used for the connecting gusset plate with the column. This is the connection of the gusset plate with the column, and this 8 number of bolts, this is 4, this is 4, these 8 numbers of bolts are used for connecting angle with the gusset plate. So 16 number of bolts are provided. If we lower the bolt by 1 or 2 numbers, we can provide by 14 or 60, 14 or 15. So now, so if we take 1 or 2 smaller number of bolts, that means if it is 13.03, we can take 14 or 15. So this type of connection cannot be provided. So we have to assume some connection in like that. So 16 numbers of bolts are selected. Now as we have got the number of the rows of bolt here, so we will go for step number 4 now. Now coming to step number 4, so height of the gusset plate will be, this is one pitch, this is edge distance, this is another pitch, this is edge distance. It has been shown here. If this is the gusset plate to connection, if this is 2, 1, 2, 3, 4, and this is 2, 1, 2, 3, 4, and this is the connection. So this is E this is P, this is E, here also this is P, this is E, this is E. So putting this value here we will get, so 150 is the height of the, so 150 is the 150 is the this value, 150 is the this angle height. So we are providing angle is equal to 150 into 115. So that value is 150 because we are providing this value 150. Also we are providing 150. Also one thing you can also see that this is 70, this is pitch 70, this is 40, this is 40. That means 40 40 80, for this is 70 plus 80, here it is also 70 plus 80. So the total length of the gusset plate equals to, that length will be equals to 300. Okay, we are getting this value 300 mm. I have shown it how to determine the value of the gusset plate height 300. We have got 300. Now length of the gusset plate will be equals to similar to the length of the width of the base plate, because length of the gusset plate will be similar to the width of the base plate, because the gusset plate is provided along the base of the column. So if the column is provided like this, if the column is provided like this, if the connection is provided like that connection, this type of connection here, if the connection is provided like this type of connection, this type of connection, then the connection is provided like, so this will be the width of the slab, width of the base plate, so width of the gusset plate, so width of the base plate is equal to 410 mm. So now the outstand of the gusset plate, that is this value, outstand of the gusset plate means this value is the outstand of the gusset plate. From here to here is the outstand of the gusset plate. So outstand of the gusset plate will be equals to 400 minus 250, that I have shown here also in the design procedure. I have shown here is equal to the outstand of the gusset plate. So now coming to the step number 4 here, step number 4, where step number 4 has step number 4, outstand of the gusset plate is equal to length of the base plate minus depth of the column by 2. So length of the outstand of the gusset plate is equal to here it will be width, so 410 minus 250 is the depth of the column 250 by 2, that is equals to 80 mm. Now S0 is equal to will be that value. S0 means that value. Now it is, we have calculated 80 mm. Now we have to calculate that. That is the difference between the height of the gusset plate and the starting point of the gusset plate. So the height of the gusset plate is 300 and the starting point of the slant is equal to 150. So it will be that height is equal to 150. So here it is also shown that the 70 plus 2 into 40, that is equals to 150 square. Only this part is equal to 150 square, only this part. So it is equal to 170 mm. It is less than 13.66 epsilon tau g. Tau g is equal to the thickness of the gusset plate. We are providing 16 mm. So 13.66 into epsilon. Epsilon equals to 1. I think you know why epsilon is equal to 1. Tg is equal to 217.66. Also d is equal to 250 mm. D is equal to that value 250 mm. So 250 less than 468.8 mm. So the column, the gusset plate is safe in buckling also. So this is the design principle of the design procedure, how to design a gusset plate. So it is very much important, and I have shown you that how to design a gusset base following all the criteria. So we have covered all the steps here, and we have determined we have done step number 4 in the latter part of the math, because we need to first determine the number of the bolts required to make the connection. So first in the step number 8, we have determined the number of the bolt required is 16 number. Then we have drawn the connection. Then we have determined the step number 4, that is the slant height and the check for the buckling. So this is the math for the column base, that is the gusset base. So in this slab base design, we have designed the column base and the gusset base, and then we have discussed how to design that, and we have shown an example. Okay, so this is up to this is the design of the column bases, slab base and gusset base. Okay, so up to this the actual compression member design is complete up to today. Next day we will discuss the most important one of the most important part of the design, that is the one of the most important part of the we will be discussing in the next class, that is the plate girder design, which is a huge design, and it will need much more time. So up to that, this is for today. Okay, thank you.